Good day, everyone. So we are the group 5, and our topic for today is chapter 13, list. So the members are Maranian Lawrence Christopher, Maravilla Carl, Molejon John Sherwin, Monte John Dave, Palacio John Dave, and yours truly, Taraga Mary Elton Loriano. So the learning outcomes would be at the end of this lesson, students are expected to first is understand and illustrate list of triangle. Second is determine the formula of angle of list, or GG1. And third is calculate the weight to load, port and starboard to bring the ship upright. So, what is list? List ship is inclined by forces within the ship. For example, when the ship is inclined by shifting, weight transversely within the ship. This is the fixed example of list. The angle of list is the degree to which a vessel leans or tilts to either port or starboard. So, a listing vessel is stable and at equilibrium. But the distribution of weight aboard, often caused by uneven loading or flooding, causes it to heel to one side. By contrast, roll is the dynamic movement from side to side caused by waves. If a listing ship goes beyond the point where a right moment will keep it afloat, it will capsize and potentially sink. Moreover, so what does it mean when a ship is listing? A listing is a nautical term to describe when a vessel takes on water and tilts to one side. A ship can list either to port, which is left, or starboard, which is right. By contrast, a ship is said to be trimming when she tips forward or backward. So the next presenter would be Molejon John Sherwin.
Thank you. So the important terms is the first is the metacenter of the ship. Metacenter of the ship is the vertical point at which an imaginary vertical line traveling through the center of buoyancy and gravity crosses the imaginary vertical line running through a center of buoyancy, generated when the body or ship is displaced or tilted in the water. No matter how a little, a floating body's or ship's center of buoyancy is the point which all of its pieces precisely buoy each other. In other words, the effective center of the displaced water, regardless of the tilt of a floating ship, such as the metacenter, stays immediately above the center of buoyancy. When the vessel is at rest on an even keel, the center of buoyancy lies immediately below the center of gravity as well as below the metacenter. Next is the initial center of gravity. The initial center of gravity of a ship is the point in which the entire weight of a ship may be considered as concentrated such that if supported at that point, the ship would remain in equilibrium. A simple example of the center of gravity is the middle of a seesaw. Knowing where the center of the gravity of the ship is located is very important because of its effect of the ship's stability. The center of gravity is measured from the keel of the ship. You will often be required to find the new position of G when cargo is moved. The distance from the center of gravity, G, to the keel is denoted by kg. Next is the new center of gravity. New center of gravity, G1 represents the new center of gravity, then GG1 denotes the ship in position of the center of gravity, and KG1 represents the distance between the new center of gravity and the keel. Also, if G represents the center of gravity of cargo loaded, discharged, or shifted, then KG represents the distance from the cargo to the keel. Next is the metacentric height. Metacentric height is a measurement of the initial static stability of a floating ship or body. It is calculated as the distance between the center of gravity of a ship and its metacenter. Larger metacentric height implies greater initial stability against overturning. Next is the GG1 distance equals distance from G to G1. So GG1 denotes the shift in position of the center of gravity. So GG1 equals distance from G to G1. Next is the weight. Weight means is just another word for the force of gravity. Weight is a force that acts of all times all objects on the near Earth. The Earth pulls on all objects with the force of gravity downward towards the center of the Earth. The magnitude of the force of gravity can be found by multiplying the mass of the object by the magnitude of the acceleration due to gravity. Next is the distance. Distance is a numerical measurement of how far apart objects and points are. And lastly is the angle of release. Angle of release is the degree which vessel heels to either port or starboard at equilibrium, with no external forces acting upon it. Listing is caused by the off-center line distribution of weight aboard due to uneven loading or to flooding. So our formulas here is GG1 equals GM tangent theta. So next reporter will be Maravilla Carl.
Thank you for that, Mr. Melijon. Now, we have learned the important terms and what is listing vessel and list all about. So this problem here is going to help us assess our knowledge on whether we really understood what listing vessel is all about. So, here is the problem. A ship of 13,750 tons displacement and has a GM of 0.75 meters is listed 2½ degrees to starboard and has yet to load 250 tons of cargo. There is space available in each side of number 3 between deck, center of gravity 6.1 meters out from the center line. Find how much cargo to load on each side if the ship is to be upright on completion of loading. So we need to load weight in tons to port and 250 minus weight in tons to starboard. So based on the problem, we get this illustration. So the problem has given us that the ship has listed 2½ degrees to starboard, which is this angle value right here, 2½ degrees to starboard, from the metacenter to the new gravity, which is G1. And we also have the value of 6.1 meters out from the center line, which is the value of starboard side, the distance of cargo from the starboard side and the port side. So we also have 6.1 meters here. And this illustration, we're going to use this to answer this problem. Now, here we're going to focus on triangle GG1M. Anyone here would like to explain how we get the formula on how to get the value of GG1?
So thank you, reporter.
So thank you so much for that, Mr. Marian. Here we are going to use the formula that we have attained earlier to get the value of GG1. So Mr. Palacio will explain this.
Thank you, Mr. Maravilla. So in order to find the GG1, Since we have our angle theta, opposite of it is the side GG1, and following given which is the GM or our adjacent. We can formulate now our formula in getting GG1. So GG1 is equal to GM times tan theta. So GM 0.75 times tan of theta is 2.5 degree. So 0.75 times 0.0437. So our final GG1 is equal to 0.0328 meters.
Thank you for that, Mr. Palacio. So that now that we have the given GG1, which is 0.0326, Mr. Monte, would you like to explain the moments about the center line?
Yes, sir.
Yes, sir.
So here are the given of the problem. Displacement is equal to 13,750 tons. GG1 or distance from G to G1 is equal to 0.0328. B is for distance is equal to 6.1. And the load is weight 2 tons to port and 250 minus weight 2 tons for starboard. The moment about the center line, weight, distance, and listing moment, the port and the starboard. To get the 451 on the listing moment in the starboard, multiply the 13,750 to 0.0328 to get the 451. 250 minus weight, distance is 6.1. To get the 1,525, multiply the 250 to 6.1. For the starboard, at the listing moment, add the following 451 plus 1525 to get the 1976, then minus to the distance, which is 6.1. After the given problem, the next reporter, Maravilla Carl, will check the following given.
Thank you for that. Now that we have the final moment to port and to starboard, we can now formulate an equation on how to get the weight that we are going to load on port and starboard. So if the ship is to complete loading upright, then we can say that the moment to port is equal to moment to starboard. So 6.1 W is equal to 1976 minus 6.1 W. So we can simplify this by transposing negative 6.1 W to the other side. So 6.1 W plus 6.1 W is equal to 1976. Then we can divide both sides by 12.2. Now we have the value of W is equal to 161.967231, or we can round that off to 161.97 tons. So we now have the value to list to port, which is equal to the value of W, which is equal to 161.97 tons, and list to starboard, which is equal to 250 minus the value of W, which is 161.97, we get 88.03 tons. Therefore, we can load 161.97 tons to starboard and 88.03 tons to starboard. We can load 161.97 tons to port and 88.03 tons to starboard to make the ship upright after loading. So, we can check this by using the value that we attained just now. So in checking moments about the center line, we can substitute the value of W with the value we obtained earlier. So we obtained W is equal to 161.97. So in here, in the table, we have weight, distance, listing moment to port and to starboard. So we have the initial, which is 13,750, multiply it by 0.0328, or the value of GG1. We have a listing moment to starboard, 451. We can do the same to the starboard side, which is 250 minus the value of W, which is 161.97. We have 88.03. Multiply 8 multiply it to distance, which is 6.1, we get 537. Then we can add both the starboard, so we get 988. So in listing moment to port, we have 161.97 multiplied by 6.1. We also have the value of 988. So we have the final moment to both port and starboard, which is the value of 988. So we can say that moment to port is equal to moment to starboard, which is 988 is equal to 988. Thus, loading 161.97 tons to port and 88.03 tons to starboard is correct. The ship is to be upright on completion of loading because the moment to port and starboard are equal. So that is all for our reporting for today, and we have accomplished our learning objectives, which is to understand and illustrate the list of triangle, determine the formula of angle and of list, which is GG1, and calculate the weight to load port and starboard to bring the ship upright. So we have accomplished our learning objectives for today. I hope you learned something from our report. That's all, and thank you.